Well, hi, good morning. Thanks for joining me in my shop here. It's April 11th, and I'm going to focus on this radio again, which is still exhibiting the same intermittent problem that I thought I had solved. Well, I didn't think I'd solved it, frankly. I was just hopeful. When I just resoldered one contact here, and the problem seemed to go away. It seemed to go away for an extra long time, but eventually back it's come. So, of course, resoldering one terminal, what I give that? I gave that a 2% chance of working. Yeah. So, an interesting observation that I did make, clearly each time I contact this particular terminal, the radio pops back to life. You can't quite see it. It's this, where this blue wire is here on the transformer. Well, what I discovered is by contacting this terminal on this tube, I also brought the radio back to life, just once. It's a one-time observation here. And I believe I tried to replicate it, it didn't replicate. But it happened once. So what is the relationship between this spot and this spot that touching them with a probe can affect the operation, restore the operation of the radio? What is the similarity there? And then the blue wire on this side goes through this metal panel. You can see it right there. It comes out and ties to this terminal. Let's find out what's going on here. I think that starts with looking at the schematic and just looking at this arrangement. And which tube is this? This is the 6K8. This is 6K7 there, I believe. 6K8. And the first IF transformer. Okay, let's take a look here. Okay, so this is the 6K8 here, and this must be the first IF. Now that's kind of interesting. No, actually, that's not interesting at all. It makes perfect sense. So you don't know what I'm talking about, but that's okay. Just talking to myself here a little bit. So the two wires I'm touching, one is one of these two terminals here. It's bound to be this one. This is the blue wire. Let me just look in the back of the radio for a second. So that comes over to pin number 3 on the 6K8. Of course, they don't bother numbering them here, do they? 3 on a 6K8. So if you'll bear with me, I'm going to look in my book. Find out what pin 3 on a 6K8 is. It's a plate. Plate on the heptode. Pin 3. So we have the plate wire from here coming across to here. And this is the wire I contacted a number of times. It has caused the radio to restore. Now, what did I contact? I contacted pin number 1, 2, 3, 4, 5. Pin 5. Well, what's that? 6K8. Pin number 5 is the grids. It's both grids. Wait a minute. Well, I shouldn't put it that way. It's the shared grid between the oscillator side of the tube and the heptode side. Wait a minute, is that a heptode or a pentode? Heptode? Hexode is what I should call it. So pin 5 is the grid of the oscillator and carries the oscillating grid voltage into the grid of the hexode. And they're both connected to pin 5. So so pin 5. So when we look here, we should see that. So here, the way they've shown it here is right here. But wait a minute, this is nothing. Did I tap? This is what I tapped. I tapped this right here. So tapping this or tapping this has restored the radio. Wow, really just screaming out that this tube is bad, but I put another tube in here and we got exactly the same response. Well, another thing that's consistent here is the tube socket. What kind of sockets are in here? It's the cheap riveted wafer type. Oh boy. Okay, let's go back and look at the radio a little more. Well, could that capacitor be a problem? Now, this is a bit of an unusual looking capacitor. This could be a temperature sensitive capacitor, I'm not sure. Yes, sure, it could be that capacitor. Sure, it could be. That's tied here, although you'd wonder why tapping the plate side would trigger it. If you tap the grid, you can kind of sort of reason that some kind of shock wave would actually go right through the tube onto the plate and carry on to do whatever it is that's doing. Based on my theory that this problem is a sort of a close contact type problem, and any little disturbance will I feel like I have to put another tube in here again, but that just seems ridiculous. So yeah, that's right. So you see the type of socket, the material here. That is here. See the rivet? One there, and there'll be one up here. There's two pieces sandwiched together, two non-conductive pieces sandwiched together with all the hardware in between, and that's what's holding this thing together. It's not much holding it together. So what happens is dirt gets in between the two wafers. See if I can get on the edge here and see the two wafers. Let me look at another one. You see there's two wafers, and dirt or moisture gets in there, and you get tracking right inside the socket. Doesn't matter how much fooling around I do, that's never going to be changed unless I do something inside the socket. And what would that be? Well, obviously change the socket, but yikes. That's a big ugly job. That's soaking it with some kind of cleaner. Yeah, you know, like you could drench it with WD-40. Word is WD-40 would soak into this material here. The oil will soak into the material and cause problems, although I've never seen those problems. They already have problems. Would it cause worse problems? So I'm looking at, nothing looks overheated on this. There's just nothing leaping out at me at all. What about flexing it? What about waiting until there's a problem? Hey, we could do this. Wait till there's a problem and then mechanically flex this surface with a stick. And if there's tracking going between pins here underneath the surface, you know what, this doesn't make sense either. Tracking, like following a carbon track and leaping at the end, is a little like a bolt of lightning, and it takes time for the charge to build across the gap that theoretically is under here somewhere, the tiny gap that's jumping. That's a kind of problem that's kind of repetitive. Something like, not quite like that, but something in that realm. Not and never come back. Never comes back. Doesn't seem to pop off, although I think I have noticed it pop off once or twice. Mostly it just seems suddenly I realize, oh, it's gone quiet. The radio's gone quiet. another thing I could be doing, I just resolder every lousy connection, everything that has anything to do with anything around here. Just do them all. And I would lay that to rest. Not too likely to introduce another problem. See the dust on the red wire telling you that's a high voltage wire? Yeah, I'm just looking around here. What do I expect to see? You notice see the ground terminal we're looking at in this radio? Looks like they've spot welded it to the chassis. There's a few of them around. Spot welded. So some crazy things I could do, which I'm not going to do, is try to voltage check, like a breakdown test between these terminals. But I'm not about to do that, but theoretically you could, particularly if there are no wires hooked up here. You could put voltage on these terminals in various ways and see how much it takes to cause a breakdown. That just, I don't get it. We should get the radio operating. Why is that? Because I don't know what else to do. I'm going to sit and stare at that thing all day. And I don't think the lights are going to come on in my head. Okay. The best thing I can do is keep rummaging around the radio, looking for more observations that might help get me out of the doldrums here. Okay, let's see if we can switch it on. Speaker. Nothing else is hooked up. Here we go. Not so sunny today, not so nice a day today. Cats are inside. They've been out already, but they're back in because it's cold. It's cold outside. There we are. So full power.
By the way,
yeah, so it's in working mode.
Franchise to go to. I should have the worst franchise in the Pacers. Yeah.
Okay, so if it's something mechanical inside the socket here, I should be able to trigger the problem by fooling around. I don't think I've ever triggered the problem. This is not stiff enough. Something stiffer. Use a pencil. Not the best idea. No. I can actually see it bending under my force. Over here. No, it's nothing. I've never been able to trigger the problem, only trigger the restoration of the problem. That's pretty interesting. Well, this is the thing about intermittent difficulties is they're really tough. I can't hunt for it right now. It's not there. I'll have to wait for the radio to fail and then go hunting. Because I cannot bring it on. What about that capacitor up in the back here? Again, doing stuff to it mechanically, it may not be doing anything. It's looking for some kind of electric thing or something electrical is going on inside it. So nothing will trigger it. Something changed there. Something changed there. But then it got louder during that. You know, it's just the volume control shaking. That's all it is.
I suppose there's a track record of Chris Letang having that same surgery in 2016 and recovering fine and resuming his career. And yes, you plan on having a 6-week recovery period, but being back for the start of the season next year. But we don't want you to have it. We think you should get some rest and recovery.
I just have to wait for it to stop working.
Control what happens to you medically because you are getting the $50 million over the next 5 years. It's so ludicrous.
Well, I just came running back in here to check to see if I could get the, if it's possible to take the covers, the cans off these two IF, or the one IF anyway. Just take the can off, but leave the IF transformer in place so I can examine it at least without, you know, desoldering it and removing it. And I came in and realized, where's the radio? There's no radio happening here. So we're already in the mode. It only took a few minutes for it to conk out. Is it really conked out? Yeah, that's full volume now. That would be screaming if it was working. Okay, so we're going to try to restore it by tapping on other terminals besides the two I know have an effect. And I'm going to do it with this lead because this seems to be the thing that does it all the time. I don't know why. I just see if there's other places that are where the sensitivity can come through. I have this too loud, or we're going to get our ears blowing off. Okay, just poking around the other transformer. Okay, this will be the tube right beside, or one of the tubes right beside the offender. That's a big ground terminal there. Look at that. All of these terminals. There we go. Okay, we'll try this tube over here because it's here. Well, this is the rectifier tube. Yeah, this is the rectifier tube. We'll leave that one out of the picture. Let's poke around this one. That's one of those welded ground terminals. So you can see I'm putting lots of, you know, shocks into the system here. You can hear them. Okay, none of that did anything. How about up around here? This is the volume control. That's the terminal. If I touch it, it should be back to life. Let's go over here now. Just keep looking for new stuff. New effects. Pretty quiet. Just, you know, this lead's actually grounded back, like the meter is grounded to the chassis. Meter's not on though. I don't care about it right now. Okay, so this tube is one that has reset the problem. Getting close to the terminals involved. Avoiding them. So far nothing. There's not much left for me to poke at. Can't imagine this. What am I doing? I'm wasting my time here. Okay, I'm going to poke the wire that has restored it once. It took a couple pokes. Nope. Is that a wild coincidence when it happened? Other ones? Not bringing it back. Okay, now I'm gonna... maybe it's broken permanently at this point. I'm now gonna poke all the terminals but the one I know does this effect over here on the transformer. This is the transformer of concern here. Nothing whatsoever from that. Okay, now the other terminal will be over here. Okay, this is the, you can call this the B plus source. And all that's left now is the terminal that fixes it every time I touch it. Let's see what happens. This is the plate wire. This blue wire is the plate wire from this tube. Come on, baby. Uh-oh. Is this thing really broken? Sure. Didn't restore. Uh-oh. Uh-oh. Wow, the number of times I've touched that and not had it restore is, I think, maybe 0. Ooh. Uh-oh, 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 uh-oh. Touch it with something else. Touch it with something else. Touch it with something else. Oh my gosh. Oh my gosh. By doing what I'm doing right now, I'm flexing the shaft that the coils are wound on up in the transformer. That's what I think I'm doing. Oh my gosh. Oh, we seem to have lost it completely now. If I remember right, under these circumstances, we can pick up a strong signal on the input side of this and nothing on the output side. We're going to repeat that test. That would pretty much, well, let's think about this a little bit. So plate current. Okay, that's enough thinking about it. We're going to listen. So I'm turning on and warming up my signal tracer here. The signal tracer is limited to broadcast frequencies, so we're on the broadcast band, we're actually listening to something. Okay, ground clip is on. We're listening to 590 the fan. So I can tune my instrument over here to 590. 590 is about there. Why so quiet? So I put this on the antenna. We should hear 590 come out of this. I'm going to turn this down a little bit. And we're going to hear if we can get 590 out of my tracer here. Something going wrong? Why so quiet? quiet there. Okay, we gotta go on enough anyway. On the antenna to hear the station. Something not quite right there. What's happening? B. There's 590. I use myself. I'm a better antenna than your antenna. It's the loop antenna. That's probably the reason why it's not working so well with this. So anyway, we can see this is on 590. Big pile of noise right next to it. 590. Just not audible. That's not a really good sign. It's there. Okay. So we should be able to find this signal arriving at grid 3 on this tube. We can't even hear the signal here. I'm going to move these leads. If you can't see what I'm talking about, I'm going to move the leads. Right now they're on the short wave antenna input and not on the broadcast. I'm going to put them on the broadcast one here and we'll see what happens. Watch the radio come back to life while I'm doing this. Green is ground. Red is ground. Not that it really matters. I'm just hooking up to the loop antenna right over here. It's actually where it really should be connected. So that's another bad sign about this radio. Anytime I try to feed a signal into these, this is kind of what we get. This might have changed a bit. It's just nothing. So either the alignment for the broadcast band antenna input is way off, or there's something more going on up there. Okay, so we're going to have to put up with the... let's try the outdoor antenna here, for what it's worth. This is usually pretty noisy. Ground antenna. Was a station there. Now I don't know what I've done. Oh my, this is going to go on for a long time, I think. I do this. Okay, let's just... nothing. Okay, so it's going to reach this tube. And it should be reaching grid 3. This one. We couldn't hear it before. Why would we hear it now? There we go. This isn't working out at all. I'm hoping to pick up the antenna signal here. Okay, we're going to stop playing with the just an antenna. I'm going to use a signal generator. I'm going to stop for a minute and get a few things set up. Okay, so the tone you're hearing now is actually the modulation from the signal generator at 400 Hertz. The radio's tuned to it. Tuning is very poor. Just doesn't seem right to me at all. But anyway, it is what it is for now. I'm feeding in the signal through the shortwave antenna. This is not the right way to do it. Let's do it the right way now with the signal generator and see what we get. just barely hear it. I can step up the power here. Doing this at 620 kilohertz. No station there. 590, 610, 640, and 680 all have stations that conceivably can be picked up here, but not 620. So again, is it definitely not working? It should be really loud at this point, I would think. Turn it up to get that hummy sound. You know what that sounds like? That sounds like an open grid to me. You know, it could be like an open grid, like an antenna, and it's managing to pick up a little bit of the signal and bring it through the radio. A grid with an open circuit. It would be the grid. Okay. You know, I checked for voltage on the plate. I was going to say I never checked for current, but you couldn't have voltage without current there. Let's use these meters, which I messed around with yesterday. I had a very good session myself here yesterday, messing around with these meters. Triggered by some comments from one of you. And all triggered from me because I mentioned that the original measurements with this radio were made with a 500 ohm per volt meter, which I think is just about the worst meter you can get. And it just made me curious about everything. Anyway, I won't go into that. The video did what it did for me. Okay, so you want to look for B plus on the plate of this tube. It's easier if you can see the meter, that's for sure. So we're on a 500 volt scale. We're looking for it, I believe. I don't know what the plate voltage is here. So that's 270 volts. I seem to remember that number. 270, that's where we were doing our experimenting with all the other meters yesterday, right on that terminal. So we have 270 volts on the plate. You can only get there through the primary from over here. This is the red wire feed to the coil, and then this is the output from the coil. This is the one that every time I touch it, it brings things back to life. Not anymore. Not anymore. Another thing that brings things back to life is turning everything off. Now, two things happen when you turn everything off. The heat drains out and the charges drain out. You turn it back on, the charges go back into position, whatever position they're going to go in, pretty quick, you know, once the radio warms up just a little bit. They have mechanical changes during the warm-up period, but that's extended for a long time. Like the radio fully warms up, every little part getting warmed up. Take a long, long time. Doesn't seem to be heat related, this problem. That doesn't seem to be. Why do I say that? The radio comes on and works for a while. Appears to go bad slowly, but like not instantly, but pretty quick, because there's no pop or anything. There's no signal that it's going bad. There's no signal it's going bad. No noise, no nothing. That was right off. I turned the set right off there, kind of like, oh, there's something new. Something new. I don't want anything new. I got enough on my plate right now. So what about injecting a signal and then working the signal back until it doesn't pass through? Well, we already know where it's failing to get through, don't we? Don't we already know that? The secondary side, yeah, we want to listen, not with that, with this. So after the first IF, in fact, even on the plate wire, You know, I should not be looking for the original radio signal. I should be looking already for IF frequency signal. I'm doing something wrong here. Let me change my guy here so it'll pick up 455 kilohertz. Go to band A, 455 right around here. Okay, so I think we should be able to get 455 right here. Did that radio just come to life? Okay, so that's coming out of my tracer. A ton of signal there. The radio's still broken. So that signal is traveling from this tube into this coil. Now it comes out the secondary side. We should be able to hear it just as well on the secondary side. This is the secondary side here. Just, you know, you have to make contact. Just anywhere in the zone. Well, it's screaming out of the second IF. Wait a minute. It's making it all the way through to the second IF? Hold on a second here, that's not jiving, is it? Okay, turn this down a little bit. And turn the attenuators on. Okay. So out of this tube and into this coil goes the 455 signal. Okay, I can see a red wire coming here. That's probably the primary. Going into the plate of that tube. Does that make sense? So that's kind of the input to this transformer. What is there? What is there? Just getting close. And on the volume control. Lots of signal there. On the secondary side of this transformer, shielded wires are going up into the tone control here. A bunch of shielded wires from right down in here. Okay, secondary side. So one side's a black wire going to this tube, and the other one is a bare wire coming up to something heading for the tone control. It looks like definitely it's showing up over here. Doesn't make sense because I say it's going to the tone control, it's going to this switch. Maybe it's finding its way to the detector. Where is the detector tube? Detector tube, I think, is this guy right here. Okay, so let's listen now to what I'd say is the output right here. Okay, oops, the volume's down on my tracer. Hang on a sec here. There's a pile of signal coming here. Oh, okay. What's happened here? I found out the signal, even though I may be affecting it up here by tapping something and bringing it back to life. Even under this condition, the signal's getting past there. It's coming all the way through to here. All the way through to here. And what is here? What is here? Now, it so happens the camera is right below the tube in question. That's the tube in question. And we make out what it is. Well, I'll have to do it just by position on the radio. Can't see it. I'm coming way around the far side here. Yeah, I'm not going to go through there. Just a little awkward with the radio upside down on my bench to oh, well. What happened there? Okay, camera fell over. It's okay now. I'm okay now. Not really okay. Just for stupidity's sake, let's just make sure this is on the broadcast band. Yeah, for sure. And it still hasn't come back to life yet. I've been in here all this time. I've done all the thingies. Touching that critical one. Oh, okay. I'm not exactly applauding here. It's good it's come back to life. Oh my gosh. It seems the same, doesn't it? You're just being totally misled by the fact that tapping up here resolves the problem. But I'm finding even when the radio's in problem state, the signal is still making it through multiple stages, right down to the detector. How that can be, I don't know. Sure seems to be the case though. I gotta wait for the radio to break down again. So when you're restoring it by tapping it with something, I think you're jamming a charge in somewhere. And in my imagination, that's closing a gap. But then after a period of time, the gap opens again, which I don't quite understand. My story doesn't quite cover that part of it. My theory. The problem could easily be a resistor too. I was thinking a bit about this. You can have a resistor with something funny inside it. Something funny has happened. Could be almost anything. Well, I'm going to have to just leave it running and come back when it's not running and carry on. I don't have many choices here. Well, it's been a few minutes. Previously it stopped working in this length of time, but this time it's hanging on. Darn it. Yeah, I don't want it working, but I do want it working, but I don't want it working. Oh my gosh. Come on, little guy, let's poke around some more. So we're down in this area now. This is kind of where I got to last time. Discovered that when it's in non-operating mode, it's still operating quite a ways, all the way to what I think is the detector tube here. I don't really expect mechanical poking to solve anything or cause anything to happen. Oh, hot diggity dog. Oh, yeah, there you are. That's an excited phrase from Jim. Hot diggity dog. Gone to the state, and I poked it there. You are coming through. I'm wasting my time here, wasting my opportunity, although it never comes back to life on its own. It could. So now we want to listen to where we can't hear it anymore. This tube, I want to verify which tube that is. So we are looking at the back of the radio here. V4, no, V4 doesn't actually tell you what V4 is on that piece of paper. Well, we're going to go with the idea it's the detector tube. The detector tube is, oh, for crying out loud, I can't. It's not on this. Okay, I have to run to another room for a moment. V4 Detector AVC amp 6SQ7. 6SQ7, that's what I couldn't remember. 6SQ7. 6S elemental PQSQ7. I want to get the pin out so I can so I know what it is I'm poking. TUV QR QR 6 QRS QR. I really need to learn that alphabet. Wait. 6SQ. Come on, Jim. I need to learn more than that. 6SQ. Oh my gosh. See, I've got a little bit excited here. There it is. Whole page on it. Charts and everything. It's very, very metal type 6SQ7. Detector amplifier AVC. Similar to 6Q7. A higher mu triode. Okay, we're just interested in the pinout really. We should go targeted. So what is happening is the signal is reaching this tube on these two pins, 3 and 4, which are the rectifier or the diodes. One is supplying AVC voltage, and the other one is carrying the audio onward. We should hear the signal at either one. We should hear. I think we should hear 455 on either one of those. We should hear the signal at 455 on either one of those. Now we discovered the signal was still traveling in the radio, even though it's not getting to the speaker, because I can do this. There it is, just airborne. So she's humming all the way up to here, and now I've already forgotten. It was 4 and 5, 3 and 4. I've already forgotten the pin numbers for crying out loud. 3 and 4 are the two detector diode. 3 and 4. So we're looking at this tube here. One, 2, 3. So this is no. Three is grounded. 1, 2, 3. Well, that's going wrong. What's going wrong there? 3. Something's gone wrong. Something's definitely gone wrong. I'm definitely seeing the post. I'm counting them correctly. I got the wrong. I bet you got the wrong number in my head already. It can happen that fast. No, 3 and 4. Wait a minute. No, 3. No, you know what it is? I have to get new glasses. It's 4 and 5. 4 and 5. 4 and 5. Can't see anything up close. 4 and 5. Well, that might explain a lot, eh? So 4 would be the next one over. Just getting close to it. Okay, move my hand on the volume here. Certainly is there. And the next one. Well, you can't really. It's hard to tell, but it's a little louder when I touch it. So apparently, the signal's being presented to the diode in that tube. So the output should still be carrying the 455, but it might be. I'm going to look it up again here. 6SQ7 wasn't it? I took a hard time finding it last time. Then I put a bookmark in. Well, that would be smart. So what happens now is the signal is stripped of its RF component fairly quickly. So even though I'm listening to 455, it's not going to last much longer beyond here. They ground it out with a capacitor. The signal ultimately, the audio signal comes back and arrives on the grid. No. Yeah. Comes back and arrives on the grid of the tube there. And that would be pin 2. So we should be able to pick up audio on pin 2. Audio on pin 2. Okay, I'll change the tracer to listen for audio. Okay. I've got the attenuator way up. Okay, audio on. Did we remember what pin it was? Oh my god! Just it's like I'm 100% live in the room effect now. Every time I turn around, I can't remember what I was thinking about. I really think it's part of the modern world. I think we're all suffering from the same. Things are moving so fast all the time. What actually happens is if you are reading Twitter and topics are jumping every time you turn around and you're not concentrating at length on any one thing, your brain will adjust itself to accommodate that situation. You actually find it very, very comfortable to be getting overwhelming amounts of information thrown at you. Your brain will have figured out how to keep you relatively comfortable during that. What happens then is, if you don't feed your brain with all that constant, Twitter crap, your brain gets hungry for it because it's adjusted now. You gotta watch out. It's a slippery slope playing around with this kind of stuff. That's why I have no Twitter account and I'm not on Facebook, for those reasons. So I can remain in control of what is going into my head. I can't control what's coming out though. That's my problem. So, okay, enough speeching again, making speeches. So grid is 2. So we should find audio on 2. Audio on 2. 2 is a little hard to get to. 2, no it isn't. Oh, I've done something entirely wrong. No, I haven't. So, well, wait a minute now. So this is a speaker output here. Will that be the, did I count right? 1, 2, I didn't count right, that's what happened. Okay, audio here. Okay, hand on the volume control. We should just hear the tone that we're hearing. We should hear it nice and loud. So, okay, now that's a good camera shot there. You can't see anything of anything. There should be a tone there. There is not. This is pin number 2? Yes. How sensitive this was. How high you have to turn this radio up to hear that. It's the same thing. Okay, I think we've nailed the problem here. At this point, have we nailed it, or we just really got close? Detector tube. Did I not try this already? A new detector tube going in. That's where I'm at. Even if I did it once, I'm doing it again. Okay, I'm gonna let things cool off a bit, including me, and we'll deal with this. Okay, we're ready to test here. Let's just double check. This is a 2. I'm going to do 2 tests on this tube. 6.3, signal level 118L, 25100, 25100, 3760, 3760, 37 F. It all checks out. We're ready to take off. First test, I think, is the triode side of this tube. And then we do actually 2 more tests to do each of the individual diodes. Okay, look for shorts. No. So part of doing the short test, a lot of recommendations will wrap the tube while you're doing it. drain 10 years out of the life of that tube. So it passes fine. So it should come up to 760, which is just about here. So this part of the tube is functioning fine. Next part, the diode. So this is no longer important. This is no longer important. We change to 2013P. 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 Okay, and 0760. 0760. So I think these are the heater. This is the heater row. I'm not exactly sure. 48 on the cheater control. This makes the meter read what the technicians who designed this wanted it to read. A. P1, P2, diode test. Up. And I pulled the tube out while I was making these changes. In some tube testers, if you change these while the tube's in, you can run into trouble. The other tube testers, it doesn't matter. They're designed so that can't happen. So you can leave the tube in and make your changes. I get a little bit forgetful about which one is which, so I tend to pull the tube out all the time if I have any doubt about it. Okay, let's check for shorts. Nothing at all showing up. Diodes and rectifiers with this switch, and it has to come up above. You probably can't see it. This point here, up in this area. This is normal up here, right where it came up. That's one of them. And the other one, same thing. So, now, could this still be the culprit? Yeah, this isn't really proven that there isn't some weird intermittent thing going on in here. Oops, wrong switch. What I need to do is put a different tube in and then see if the problem will replicate. 6SQ7. Okay, I'm going to dig one out and stick it in there and we'll try it. Okay, so that's the replacement in there, and we're starting with the diode test. That's how this was left, so we'll just start with that. Shorts, no shorts showing up. Diode test with P1. There we go. About the same as the last tube. P2. A little lower there, but functional. Now we're going to switch to the testing the triode. Diode again. Signal level 1, 18L. 25100. 25100. 3760. 3760. Okay. Gotta get that right. 25100. 25100. 3760. Yep. 37 over here. F. Okay. Don't want to have this wrong and push the test button. F. Shorts. None. Test. Okay, so it's a it's okay. This is a good tube. It's gonna work. Okay, so I'm gonna put this in the radio now. This is the new one. And we're gonna turn on the radio, get it working, and then I'm gonna go. I guess at lunchtime. No, it's nowhere near lunch. Go do something for a while. So putting the tube in. Putting the tube in and taking it out, because of the way you wiggle it in. I was just watching the socket and the whole thing's being manipulated strongly, just putting a tube in and out. If there's something going on in the socket, surely to goodness even that would cause a variation in the behavior. If it's like a shorting inside the tube socket. Okay, it's in there. what else is there to do other than turn it on? Turn it on. Okay, a little dim bulb action there. All is good. Now I expect this to work. My expectations don't mean anything though. But in reality, you know what? It's not working. It's in its dead state. Well, that pretty much eliminates for sure that tube. And now I'm gonna, because it's cool, I'm gonna wiggle it around like crazy. Let's see what happens. Just like I'm putting it in. Look at that. You can't look at that. Here. Just watch me distort the socket down there. Nothing happening. Nothing whatsoever. I really think this problem is internal to a component. That's what I really think. And it's not the tube. Don't think it's a socket, because surely to goodness that would have done something. If there was some kind, it would be scratchy. It wouldn't be as solid as it is. This thing goes into a solid failure mode. Didn't I poke it out? Didn't I poke it out by poking around down here? Yeah. Oh, that's it. What's it exactly? I'll give you a little 3D. There you are. That's poor man's 3D TV. It's this black wire coming from here. And I move that black wire. Click, click. Ooh, did it just do it? Is it this end? This is going right into the coil here. Okay, or is it this end? Is it that? Is it neither end? It's the middle. It's the middle of the wire. So the middle of the wire, if you push on the middle of an arc, it drives out the ends. You know, it almost looks like the wire's broken right there. It almost looks like, I get the close-up camera on it. I think I can see an actual break in the wire. Oh my God, what a journey. I spent too much time fishing in the wrong pond. Okay, this is a live radio and a live camera. So I got it about dead center of the screen is the wire in question. And you can monitor my heart rate by watching the camera shake, by the way. Looks like my heart's going a million miles an hour. A little bit of green on that wire. Ooh, what happened there? I think I touched it with the frame of the camera. No, I couldn't have. I don't know what happened there. It does look a little green. I mean, all these wires look egregious in here, don't they? They look like stuff's growing on them. There's a wonderful solder job there I must have done. It's not a lap. That's a hook. It's a hook job. That's okay. Well, let's resolder that, because I think that's the problem. Right dead center of the screen there. Or, I turn the set off. Let's see how hard it is to break the wire right there. I'm going to get a grip on it. I can steady up the camera a little bit here. Okay, I'm going to go in. Well, it's hanging on pretty tight, but look at how loose the terminal is. Can I get right on the terminal? Not really. Is there not a pin? Sometimes there's no pin. Oh, there's a pin in it. That seems really weird. I mean, how can you wiggle the terminal and not wiggle the other part? Let's find another example. Okay, let's go down here. Now, this is really soldered up in place, but You know, I mean that's held by too many wires. I mean, if one's got nothing soldered on it, but it has a pin in place. I gotta find another. Okay, here's one. It's a different tube. I'm gonna grab this. I don't think it should be that loose. Here's one with no pin. Now that's loose. But you see, it's the same piece of metal, right? It's one piece of metal from here to here to here. Yeah, there. Well, let's go back to the one in question. Okay, it's about dead center now. Now look at the wire. Yeah, you know, that just doesn't look good, does it? The wire looks solid. The problem is in the socket. And the solution would be to solder right onto here. Actually get a wire, wrap it round and round, and then solder it. Just tack it onto the back of this and solder on there. That would be the solution. Okay, hey, I think I got it. How did that ever happen? No, but obviously the repair is obvious, so I'm going to do that, and then we'll try the radio again. I mean, how could they break? How could this even really be what it appears to be? That's probably something a little different than what I've deduced. This is just not going very well here. Let's stick some more solder in. Looks like I got it. It's pretty solid. Okay, put the tube back in. That's a weird one. I will have resoldered this black wire connection just coincidentally while doing that, just in case it was really a cold solder joint there. One way or another, I think I've got it. Okay, we're going to switch on. Get a little radio. Everything ready? Sure. I'm going to have to bring it on. It's almost certainly going to work because it usually does. I'm going to have to leave it. It's still not lunchtime. Oh my gosh. Where'd the go? That's interesting. Huh. Could, I don't know. Oh, you know what? We don't have it on full voltage. That's what it probably is. Full voltage. Give it a moment. No. Kind of a bit of a sudden volume control here. Yeah. Okay, that's not a problem I'm too worried about. So we'll just leave this guy running. Hey, let me wiggle the tube. Let's take a gamble here. Not doing anything. Let's push on that wire. Push upon the wire. Not doing anything. Okay, we're gonna leave it running. We'll come back in a while and see what we got. Still working. Well, the radio's working just as good as ever. I think I've nailed the problem. Now, I did say that once before, didn't I? Okay, very good. What I'm going to do is I'm going to leave this radio running this afternoon while I go about doing other things. I'm going to end this video at this point, and hopefully tomorrow, when I start up, it's all about finishing the alignment on the radio and being done with it. Wow. Okay. Thanks a lot for watching, and I'll see you at tomorrow's video, and hopefully this radio will still be working. Well, I'm just finishing up on preparing the video that you just are watching, and this last little piece here, it's been playing for an hour, and still playing. I think it's fixed. Thanks again for watching.